In this video, we're going to cover inequalities dealing with quadratics. I'm going to go over 3 examples, and you can actually find these examples in your practice worksheet. So you don't have to worry about doing these on your paper, but we're going to go over these 3 to hopefully clarify any concerns that you might have when it comes to solving by factoring or dealing with inequalities or dealing with intervals for which you might be above or below a certain line. So with that said, let's go ahead and take a look at our first example. This is number 1 on your worksheet. It says x squared minus 11x plus 19 is less than negative 5. Now the first thing you need to notice is that this is a parabola, and we are asking for when the parabola is less than negative 5. In other words, we're asking for when the parabola is below a height of negative 5, if you'd like to say that. So what I want to do is kind of just get a rough idea of what this looks like. And what I need to recognize is that since this is a parabola, and the a value is a positive number, see, a is positive 1 in fact, that means this parabola is going to open up. So I'm going to draw a parabola that opens up. I don't really care where the y-intercept is or the axis of symmetry or anything like that. I just want a parabola that opens up. And then I need to draw a horizontal line. I need to draw a line that represents the line y equals negative 5. So there's a line that represents the negative 5. Now let's reread what this question is saying. It says the parabola is less than negative 5, or in other words, the parabola is below the line. The parabola is below the line. So if I were to identify the region that is below the line, well, the region that is below this line is this whole area in here. So I'm going to go ahead and shade that in just so I can see that. Now that will help us answer the question later on. But we are looking for the part of the parabola that is below the line, or in other words, the part of the parabola that's in the red shaded region. So with that said, let's go ahead and do some work to get some answers. The first thing I want to do is treat this inequality as an equal sign. So let's just rewrite this equation. So it says x squared minus 11x plus 19 equals negative 5. The solution for this equation will be the bounds of our inequality. So this is a quadratic. We've worked on solving quadratics for quite a long time now. And so remember, to solve a quadratic, the main way to do it is factoring, or you could do the quadratic formula. I want you guys to focus on practicing factoring. So remember, to solve by factoring, you need to make the equation equal to 0. So since we have the parabola is equal to negative 5, in order to make this equal to 0, I'm going to add 5 to both sides. Remember, whatever you do to one side, you have to do to the other. And so when I add 5 to both sides, this 19 turns into 24, because 19 plus 5 is 24. So we're combining like terms here. So we end up with x squared minus 11x plus 24 equals 0. And then from here we're going to factor. Remember, we're always going to look for GCFs first. In this case, we don't have a GCF greater than 1, so we can skip that step. Then we're going to do our quadratic factoring. So that's when we set up our x. Remember, the thing on top is a times c. So a is 1 and c is 24. So we're going to get 24 on top. And the number on the bottom is your b value, which in this case is negative 11. We're looking for something that multiplies to 24 and adds to negative 11. Because it multiplies to a positive number, they either are both positive or both negative. And because it adds to negative 11, that's going to tell us that we want 2 negative numbers. And that would be negative 3 and negative 8. Now, from here, we're going to go ahead and factor. Remember, there's a shortcut to doing this, or there's the long way. Remember, the long way always gives you the appropriate factors. But if the a value is 1, then you can use a shortcut. These are your factors if a is 1. So our factors are x minus 3 and x minus 8. Okay? If the a value is 1, then you can just go straight from your x and write your factors. We'll go over an example where the a value isn't 1 in a minute, so you can get a quick review of that. Now remember, from here, we have 2 factors that multiply to equal 0. Well, in order for that to be the case, one of those factors has to be 0. So I'm going to set each factor equal to 0. I'm going to say x minus 3 equals 0 and x minus 8 equals 0. And then from here we're going to solve each of these equations. So we're going to add 3 to both sides, we get x equals 3. Then we're going to add 8 to both sides, we get x equals 8. This process we've gone over for months. So if you're still kind of sketchy on how this looks, go over this video, go find on Khan Academy or YouTube or something that talks about solving by factoring. But from here, we notice what we just found is where the parabola equals -5. So we know that this parabola over here equals this line when x equals 3 and x equals 8. In other words, we just found the x values of the intersections of those two functions. So we can say that this point has an x value of 3 and this point has an x value of 8. Now from here, I want you to recognize something. I want you to recognize that we have a parabola and we have this line, and this line cut the parabola actually into 3 different pieces. It cut it up like scissors. It cut it in 2 places, forming 3 different parts. We've got this part of the parabola, this part that's above the line, we have the curvy part that's below the line, and then we have the other part that's above the line. So we can actually cut our domain into 3 intervals. The first interval is for this part. This part is from -infinity to 3. So we'd say -infinity is less than x is less than 3. The next part of this parabola is the curvy part. So if I'm just tracing this, it's -infinity to 3, and then the next one would be from 3 to 8, and the next one would be from 8 to infinity. So we can say 3 is less than x is less than 8, and the other one is from 8 is less than x is less than infinity. Now notice I don't put equal signs on any of this because there's no equal sign in my original inequality. Now notice there are 3 parts to this parabola. 1, 2, 3, 1, 2, 3. It will always look like that. It will always be -infinity to the first point of intersection, then the first point of intersection to the second point of intersection, then the second point of intersection to infinity. Okay? Now from here we have to figure out which one of those inequalities we want. Well, notice the part that I shaded, how many parts of the parabola are there in the shaded region? There's only one part. It is the part that goes from 3 to 8. So that is the piece that we're looking for. Our final answer is 3 is less than x is less than 8. In other words, that parabola is less than that line over that interval. So that parabola is less than -5 over that interval. So that's number 1. Let's go ahead and take a look at number 4 now. Notice in this one we have an a value that's 3, and the inequality switched. We also have an equal sign under our inequality. So here we are looking for the part of the parabola that is greater than or equal to 5. So the first question we need to ask is, which way does this parabola open? The parabola opens up because the a value is positive. Then I'm going to draw the line 5. So I'm going to have that same basic picture in every diagram. Okay. Then from here I'm going to shade in the part that I am considering. We are looking for the part of the parabola that is greater than 5, or the part of the parabola that is above the line. So we're going to be looking for this part now. So this one's a little bit different, but the work is going to be very similar. Okay. Now from here we set our parabola equal to -5. So we're going to solve it just like it was an equal sign. And we're going to solve that just like we did before. So we're going to solve by factoring. Subtract 5 from both sides, so the parabola is equal to 0, so the function is equal to 0. And then we're going to factor from here. So the top, remember, is going to be a times c, so 3 times -12 is -36. And the bottom is your b value, so -16. You're looking for the number that multiplies the -36 and adds the -16. So since it multiplies the -36, one of them has to be negative, the other one has to be positive. Because it adds to -16, the bigger one has to be negative. And so we end up with two factors of +2 and -18. Now, we can't just go straight into our factors from here like we did on number 1, because our a value is not 1, our a value is 3. So we have to go through the whole expanding and grouping process. So remember, we are trying to replace the -16x with 2 expressions that are equivalent to -16x. And that's where the 2 and the -18 come in. We're going to write down 3x squared, And then instead of negative 16x, we're going to put plus 2x and then minus 18x. Okay, you can see that 2 minus 18 is negative 16, and then we're going to keep that negative 12 there. So hopefully you can see that this line here is the same as this line. The 3x squared is the same, the negative 12 is the same, the negative 16x just got broken into 2 and negative 18x, and that's from our x here. From here, we're going to group our first two terms and look for our GCF. So the GCF out of these two is actually just x, and then what's left over is going to be 3x plus 2. The GCF on the second guy is negative 6, and then what's left over will be 3x plus 2. You know you did it right if the things inside the parentheses match. Okay, so that's equal to 0. And then from here we have our factors. Our first factor is the values that are outside the parentheses, so that'd be x minus 6. And then our second factor is the things inside the parentheses if they match, which is 3x plus 2. If they don't match, if those inside parentheses don't match, then something's wrong, you can't go any further. But anyways, from here we use our zero product property, so we're going to set each factor equal to 0, so it'd be x minus 6 equals 0, and 3x plus 2 equals 0. Solve each one of those, so I'm going to add 6 on the first one, we get x equals 6. And the second one is two parts, we're going to have to subtract 2 first, so we get 3x equals 2, and then we're going to divide by 3, which gives us x equals negative 2/3. Okay, so there's our two solutions to this equation when they're equal to each other. What that tells us for this inequality is that these two x values are where the parabola and the line intersect. Now make sure that you put the values in ascending order. In other words, the lower value should be here and the upper value should be here. So the lower value is negative 2/3 and the upper value is 6. So we have these 2 points. And again, we cut this line, cut the parabola into 3 pieces. The first piece is always from negative infinity to our first point, so negative infinity to negative 2/3. Notice I put an equal sign here now, so it's less than or equal to, because this has an equal sign here. And then our next interval is from negative 2/3 to 6, again both with less than or equal to. And then our third interval is from 6 on to infinity. 6 is less than or equal to x is less than infinity. From here, now we have to ask ourselves, well, how many parts of my parabola, there's 3 parts here, how many parts are above the line, or how many parts are in the shaded region? Well, we have 2 parts. We have this piece and this piece. We have the first piece and the last piece. So these 2 things are our final answers. So we would write it like this. We'd say negative infinity is less than x, it's less than or equal to negative 2/3. And then we'd also say, or 6 is less than or equal to x is less than infinity. So that's another example, and that example helped us understand when the a value isn't 1, and it helped us understand when we have an equal sign in our inequality. And it also talked about the different part of the parabola, so when you have 2 answers. We're going to go over one more example, and this example is number 7. Notice in this example, the a value is negative. Well, going through the same process, we want to graph this parabola, but this parabola opens down. So there's my parabola that opens down, and then there is my line that represents the number 2. Okay. Now let's go ahead and shade the piece of the parabola that I want. Well, I want the part of the parabola that is less than or equal to 2. In other words, I want the part of the parabola that's below the line. So we're looking for below the line here. And you can see how many parts of the parabola are below the line. Well, we see the 1 part and the second part. So let's go ahead and solve this just like we did before. We're going to make this an equal sign now, treat it like it's equal, and then solve it from here. Remember, my goal is to always try and make the a value positive. That just makes things easier. So I want to move all of this stuff over to the other side. So since the a value is negative, we're going to move everything over to the other side. So in this case, we're going to add x squared, subtract 10x, and then add 22 to both sides. And so that's going to leave us with 0 on the left-hand side. And on this side, we're going to combine the 2 with the 22. So you'd end up with x squared minus 10x plus 24. And then we'll go through our factoring process. Remember, look for GCFs. There aren't any. Then we do our x. A times c is going to be 24. And then the b value is negative 10. So it multiplies to 24 and adds to negative 10. That's going to be negative 4, negative 6. Because now the a value is 1 in this equation, I can just write my factors. So it would be 0 equals x minus 4 and x minus 6. So we can just pull those from our work over here. Again, if the a value is not 1, then you have to go through the whole grouping process, which I showed you an example of on the previous problem. From here, we're going to set each factor equal to 0. So 0 equals x minus 4 and 0 equals x minus 6. And then solve each one of those. So add 4, we get x equals 4. Add 6, we get x equals 6. And so these are the 2 points where the parabola and the line intersect. Remember to put them in the lowest one first and the highest one second. So it would be at 4 and at 6 here. Now, again, 3 parts of this parabola. There's this piece, and then there's this piece. I'm going to go ahead and write them all down. The first one is from negative infinity to 4. And oops, I have a little bit of a typo here. I shouldn't have an equal sign on that infinity because a number can never be infinity. So I'm going to erase that. So negative infinity less than x less than or equal to 4. And again, it's got the equal sign on the 4 because our original inequality had it there as well. And then our next interval is from 4 to 6. So 4 is less than or equal to x is less than or equal to 6. And our last interval is from 6 to infinity. So 6 is less than or equal to x is less than infinity. Now from here we recognize that the part of the parabola that I want is the part that's below the line, the part that's in the shaded region, and so there's 2 pieces that are in the shaded region, the first piece and the last piece. So these 2 things are our answers. So we say negative infinity less than x less than or equal to 4, or 6 is less than or equal to x is less than 8. So this wraps up some examples of quadratic inequalities. I want you to go and practice the worksheet that is posted and input your answers. If you have any questions on this, you can attend the office hours tutoring through Zoom. So with that said, I will see you around next time.